As we all know that electronic configuration means we studied that the arrangement of electrons, we used to call it as simply electronic configuration. So electronic configuration, we are having a lot of importance. As I told you in yesterday's class, we can identify either it is a metal or non-metal. We can identify what is the charge, how many electrons it can donate, how many electrons it can receive. So of course, that is all we are going to discuss now. So electronic configuration, if you want to say simply, it is a complete details about an element, complete profile of an element. I already taught you. Am I right, everyone? So it is a complete profile it will give. So that is what we used to call it as electronic configuration or electron arrangement. The arrangement of electrons, the arrangement of electrons in different shells is only known as electronic configuration. So now we're having various cells, that is what K shell, L shell, M shell and N shell. So actually energy level, so this discrete energy, the energy order is different for different cells. So who is having maximum energy? Everybody? Yes, please. The N shell, which is far away from the nucleus. So the shell which is nearest to the nucleus, is having the lower energy or higher energy? Is everybody? Yes, please. Lower energy. So the shell which is closer or nearest to the nucleus is always has lower energy. That is you have to remember. So next, in each shell, what is the maximum number of electrons? How we can find? Everybody. So by what is the scheme we are having to find the maximum number of electrons? Bohr-Bury scheme. So what is the formula? Bohr-Bury scheme. You cannot be like this, 2n square. So according to 2n square, so we all know name of the shell, K shell, L shell, M shell and N shell. So shell number 1, 2, 3, 4. So we all know that what is the maximum number of electrons here? 2 into 1 square, which is equals to 2. Next guys, 2 into 2 square is equals to 2 into 2 square, 4, 4 2s are 8. Next 2 into 3 square is equals to 18. 2 into 4 square is equals to 16. So this is the maximum capacity. Maximum capacity to accommodate electrons. So in a particular orbit. Okay. So that is what you have to remember. So, oh, sorry, Amma, here 32. 32. Thank you, Laksha. Okay. So this is what we all studied in the yesterday, before yesterday, and yesterday offline class also. And I hope I have taught you 3 points regarding electronic configuration. I need response from the people. Am I right? 3 points we discussed about the electronic configuration. Yes or no, guys? Please tell me. Yes?
sir.
Yes, that is what. So, and once again, I'm saying you. So please remember, X is the symbol of the element and subscript will defines the atomic number and superscript will define the atomic mass. Atomic number means only number of protons. Atomic mass means number of protons plus number of neutrons. So that is what we'll say is atomic mass is a number of protons means atomic number plus number of neutrons. So please learn these formulas. Without knowing this, we cannot able to do anything. So we are going to solve exercise also, you will experience it everything. So I hope you all understand. Anybody having any doubt, you can ask me. Now, in our book, they have given composition of an atom and electronic configuration of first 18 elements. But of course, we will study up to 20 elements. And after 18th, sir, why sir only they have given 18? Okay. So that point, Mari, what happened? What are these points says about, sir? 3 points I told you, correct, Mari, about electronic configuration. Is it as like last cell, valence cell has max. What is the maximum number of electrons? If valence cell is the K shell or L shell or M shell, 8 electrons. That is what you have to remember. Okay. So now, if you take in our NCERT book, you can all see here they have given first 18 electrons, like first 18 elements. So you all can see the names also. So the structures and everything given, but even the structures are not proper because I will modify the structures into number of protons and number of neutrons also. So that is even more perfect actually. So now what is this name? Everybody tell me. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Neon is a what gas? Everybody. Ideal gas. Yes. Noble gas or ideal gas. Next, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. So after that, two are there. So if you learn to, argon is 18 and potassium is the 19. Potassium and the last one is calcium. At least 20 elements you have to know it. So potassium symbol you already know. So what is the symbol for potassium? Everybody, K. Calcium symbol, C. Okay. So please do it. Any doubt? Please let me know. So now, here they have given down Ca. So now they have given the composition of atoms of the first 18 elements with electron distribution in various cells so that we can find the valency also and everything. So let us add one more column, that is what representation or atomic notation. In our book itself, you can write that one. So atomic notation also. So atomic notation means you already studied just now, I taught. So what is atomic notation? This is what we used to call it as atomic notation. Do you all understand what I'm saying? 19th element is potassium and 20th element is what, guys? 19th element is potassium, 20th element is calcium. Okay. So now all of you observe. First element, hydrogen. What is the symbol for hydrogen, everybody? Yes, please. What is the symbol for hydrogen? H. And number, atomic number. Atomic number how much? 1. Number of protons? 1. So the one and only element whose atomic number equals to mass number. Who is that? Anybody?
Hydrogen.
Right. Number of neutrons? No. Number of electrons? 1. And only how many shells are there? Hydrogen. Only one shell, K shell. So that is what? L shell, M shell, N shell not existed. So that is what it is not. So valency. What is the valency? Only one is there. One is the valency. I already taught you in yesterday offline class. So once again, now I will teach that and I will come back. Okay. So if only one electron is there in valence cell, what is the valency? Everybody. Yes, please.
1.
1. So valence electrons, note it, those were absent yesterday. Valence cell electrons. Valence cell electrons 1, 2, 3, 4, 5, 6, 7, and 8. Next, what about the valency? Valence cell electrons 1 means valency also what? Everybody, 1. 2 means 2. 3 means 3. 4 means 4. 5 means what? 5 means 3. 6 means what? 2. 7 means what?
1.
8 means what? 0. That is only ways to call it as what rule? Everybody. Octet rule. What is the rule we used to call it as? Octet rule. Understand? So when the atom will become stable, everybody. When it has, when the atom will become, guys, when it has how many electrons?
8 electrons in valence shell.
In its valence cell. When it has 8 electrons in its valence cell, the atom will become stable in nature. If not, it is unstable. So that is what you have to remember. Anybody having any doubt, please let me know. So else we'll proceed from here. Clear? Mr. Darshan and as well as who is Lingesh, modify everybody names, then we'll proceed. So that is what. Till here, anybody having any doubt, please let me know, or else now we'll continue. So last notation, atomic notation. So what is atomic notation? H and down atomic number 1, atomic mass also how much? Atomic mass also how much, guys? 1. Next, helium. What is atomic number? Helium 2. Number of protons 2. Number of neutrons also 2. And number of electrons also 2. What is the distribution? K shell. How much K shell? Only 2. Over. So it has helium having only how many shells? Helium has only how many cells?
One shell.
One cell. And that cell is a K shell. So it is a special case I told you yesterday. It is only one shell and 2 electrons is there. Then also what is the valency? Then also what is the valency? It is already stable. Helium.
0.
What is the valency? Everybody. Yes, please.
0.
0. So what is the notation? Helium. What is atomic number? Atomic number means only proton. Atomic mass means protons plus neutrons. How much? 2 plus 2.
4.
4. Please speak and do it. Next, lithium. Lithium you can see 2 comma 1. So only valence electrons is 1. So valence is also what? 1. Valence electrons are 2. Valence is what? 2. Valence electrons are 3. Valence is what? 3. Valence electrons are 4. Valence is what? 4. Valence electrons are 5. So 8 minus 5. What is the valency? 8 minus 5. Valence is what? 3. Next, 6 electrons. 8 minus 6. Valence is what? Valence is what? 2. 7 electrons. 8 minus 1. What is the, 8 minus 7. What is the valency? 1.
1.
Next, 8 electrons. 8 minus 8. What is that? 0.
0.
That is only, what is that gas? Everybody, check it. What is that gas?
Gas.
Noble gas. What is the name of the gas? Neon.
Yeah.
Again, argon will come. Argon, you can see. Again, 8. 8 minus 8. 8 minus 8, what? 0. 8 minus 7, 1. 6 minus 6, 8 minus 6, 2. 5 minus here, 8 minus 5. 8 minus 5, 3, and as well as 5. Sorry, 3 comma 5. What is the element? Notice it, everybody. What is the elements? Yeah, phosphorus. So the elements who can shows more than one valency, this is called it as variable valency. What is to call, everybody? Variable valency. Okay. So this will possible only when different cases. Conditions are different. So when based upon the conditions with whom it is reacting, it may donate 3 electrons or it may donate 5 electrons. So that is what we used to call it as variable valency. So that we will study in detail. Okay. So even in class 10th, we will study that. Iron also it will come. Iron also it will show variable valencies. So clear? Understand? Mari, what Mari? Your question? So then why we are saying carbon's valency as 2 instead of 4? Where we are saying carbon valency 2, Mari? 4 only we are saying. See, carbon valency, number of electrons are 4 and valence electrons also 4. Valency is also 4. Do you understand? Carbon never be 2 plus. Clear, Mari? Carbon always valency is 4. Understand, everyone? Why valency? Because it will never donate, it will never receive. Only what? If 4 electrons are there in valency, no accepting, no donating. What it can do, guys? Everyone? It will be sharing of electrons. That is what you have to remember it. So, Now for all the elements, you start writing this now. Notation, lithium. What will happen, lithium? Li 3, and here you count it. Number of protons and neutrons. 3 plus 4. How much, Ra? 3 plus 4. 7. Please learn. Next, this two for atomic mass. Atomic mass. This together we used to call it as atomic mass. So please note it. So lithium over. Next, beryllium. What is the symbol for beryllium? Be. So Be atomic number is 4. Atomic mass is how much? 9. Yes or no, guys? Yes, please. Next, carbon. Carbon atomic number is what? Oh, boron is there. Boron atomic number is 5. Atomic mass is 5 plus 6. How much, Ra?
Double.
11. Carbon atomic number is 6. 6 plus 6, how much, Amma? 12.
12.
Nitrogen atomic number is 7. Atomic mass is 7 plus 7. How much, Amma? 7 plus 7, how much, Ra? 16.
14.
14.
14.
Oxygen atomic number is 8. 8 plus 8, how much?
16.
16.
16.
Have you noticed it? Atomic mass is approximately double of atomic number. Have you checked it? But not it is true always. Always it is not true. Approximately I am saying. Are you clear, everyone? Yes, please. Next, fluorine. Fluorine atomic number is 9. Fluorine atomic number is 9. What about the atomic mass? 9 plus 10. How much, Ra? 9 plus 10,
19.
19. Neon, atomic number is 10. What about the atomic mass? Neon, atomic number is 10. Atomic mass, 10 plus 10.
20.
20.
Okay. Next, sodium, atomic number is 11. Atomic mass is, what is the atomic mass of sodium? Everybody.
23.
23. Approximately it is double. Next. Magnesium, atomic number is 2. Everybody trying to say one question so that you'll remember. Magnesium, atomic number is 12. Atomic mass is 12 plus 12. How much, Amma? Magnesium,
24.
12, 24. Next, aluminium, atomic number is 13. Aluminium, atomic number is 13. Atomic mass is how much? 13 plus 14. Everybody.
27.
27. Very good. Learn. Silicon. Atomic number is 14. Silicon. Atomic number is 14. Atomic mass. 14 plus 14. How much, Amma?
28.
Okay. Next. Phosphorus. Phosphorus atomic number is 15. Phosphorus atomic number is 15. Atomic mass 15 and 16. How much? 31.
31.
Next, sulfur. Sulfur atomic number is 16. 16 and 16. How much, Amma?
32.
Sulfur.
32.
Next, chlorine. 17. 17 is the atomic number. So 17 and 17. Sorry, 17 and 18. How much it is?
35.
35. Okay, 17 this side. Sorry. Only left hand side you have to write. Next, argon. Argon, how much, everybody? Argon, 18. 18 plus 22. How much, Ra? 40. Yes or
40.
no? Yes. Next, potassium and as well as calcium. So, potassium, 19. Atomic number. Atomic mass is 39. Means, remember everybody, 19 protons and 20 neutrons. 19 protons and 20 neutrons. That is what potassium. Potassium. Potassium symbol is what? Pia, Hasini. Potassium
K.
symbol is what? K. Next, calcium. So calcium, remember 20 is the atomic number. Atomic mass is 40 because 20 protons and 20 neutrons. So up to 20 elements, at least you have to learn. But otherwise, if you learn up to 30th element, that is what zinc, I am very happy. So up to at least 30th element, zinc. So it will be more even good for you people. So that is what is the expectation. So I hope you all understand, everybody. Now, if you go through these paragraphs, you will find it duplet rule and as well as what is that? Another one.
Octet rule.
So outermost shell, so 8 electrons. So please learn it. So you have to go through this and you have to make it. So now that maximum combining capacity only we used to call something. What I said, maximum combining capacity. That is only called valency. Valency is the maximum combining capacity. Maximum combining capacity of an element, of an atom. That is what we used to say. So if valency is 1, 2, 3, we can say metals. If it is 3, 4, 3 to 1, like that is what 5, 6, 7, we used to say what? Everybody, non-metals. Understanding? If valency is 0, we will say what? Everybody, noble gases. Okay, wa? Ellame? You all understand, ma? Everybody's? Yes. So valency is 4 means maybe some metals, metallites basically we says, some non-metals also shows. That is why I am not showing you that anything. So valency is 1 to 3 metals. Valence electrons are 5, 6, 7. That is what we used to say is non-metals. So by seeing the electronic configuration, we can classify, that is what importance of electronic configuration, significance of electronic configuration, and then we'll proceed it. So significance of electronic configuration. All of you keep it. Significance of electronic configuration. So what you feel, everybody? What is the significance of electronic configuration? Anybody? What you are feeling? We will come to know the size of the atom. Am I right or wrong? Because we all know number of cells will come to know. Is it right or wrong? Everyone, please respond, guys. Some
Yes,
atoms,
sir.
you all know, hydrogen has only how many cells? Hydrogen has only how many cells?
Only one.
1. Understand? If you take helium also 1. But if you take carbon 2, 4, it is 2 cells. If you take silicon, 3 cells. Like that, if you take calcium, it has 4 cells. Like that, we'll come to know the size of the atom. So that is the first significance. To know the size of atom. Next, second significance. To locate the position of an element. To locate in periodic table, to locate the position of element. I will save this, don't worry. To locate the position of the element. So we can find position of the element in where? In periodic table. Where? Everybody? Periodic table. Sir, how sir this is? I will show you now. Okay. Next. Third point. This is only important point. We can identify either it is a metallic or non-metallic in nature. Is it okay, guys? We can identify or not? All of you. Non-metallic in nature. All of you understand? Please respond. If the valence electrons, if an element has valence electrons 1 to 3, valence electrons is 1, 2, or 3, they call it as a what? Metals or non-metals? They are called it as metals. If valence electrons, valency not, valence electrons are 5, 6 or 7, then what we used to call them? Everybody?
Non-metals.
Okay, that is what. Next, metalloids. Metalloids, what is that? 4. Of course, non-metals also will be there. So 4, example, 4 is there means we can say metalloids. Okay. If suppose 8 electrons, valence electrons are 8. Valence electrons are 8. We used to call it as a what? All of you? Noble gases. That is what. So up to here, finish it just minute of time. We'll so now this is what is that. Now, as I told you, second point, what is the position of an element in a periodic table? So let us go to that and you all can see. So what is the position? You will understand. So if you take, for example, periodic table, if you all notice it and you can type just in Google. So periodic table. So if you see here, this is what is the actually periodic table will says. All of you observe very carefully. So forget about the hydrogen. So hydrogen is the lightest element, which is at the first in the periodic table. Helium is at the second. Next, lithium, beryllium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Same way, sodium, magnesium. Next, you can see here, boron, carbon, everything it is going. So up to zinc means 30. Zinc, it will come here. Sir, how you can identify? Based upon the electronic configuration, you can locate the element. Sir, how, sir? You see now here. So lithium, atomic number is 3. So what is the 2, 1? Sodium, 2, 8, 1. Potassium, 2, 8, next what? Potassium 8 means 8, 1. Am I right, guys? Please respond. 2, 8, 8, 1. So rubidium also. Have you noticed that everywhere what is the valency? What is the valency, everybody's?
1.
Yes, please. 1. So that is what electronic configuration. So we can identify, suppose beryllium you take. Beryllium, what is the valency? Beryllium electronic configuration, tell me, fourth one. 2, 2. 4. 12 means what? 2, 8, 2. Calcium means what? 2, 8, 8, 2. Have you noticed it? Everywhere valence electrons. How many valence electrons?
2.
2. Same way you take carbon, silicon, germanium, this SN, tin, lead, fluorine, fluorium. Everywhere, what is the valence electrons? 4 will come. Understand, everybody? Carbon, 2, 4. Silicon. Silicon, what is atomic number? Check it, everybody. 14. Silicon atomic number. What will come? Silicon.
2, 8, 4.
4. So that is what it is. Understand, everybody? Same way, nitrogen, 2, 5. Phosphorus, 2, 5. Sorry, that is what? So phosphorus, what is the atomic number? 15. So 2, 8, 5. Do you all understand? So like that, that is only based upon the electronic configuration, we can locate the position of an element. So now you see, these all are metals. These all are non-metals. These all are noble gases. This metals to non-metals, it is, if you are moving from left to right side of the periodic table, you are moving towards the non-metals to non-metals. That is only the advantage of electronic configuration. You can locate where the metal given element will be in the periodic table, either left side or right side or in the middle. Based upon the electronic configuration, we can identify where the metal or non-metal is located in the given periodic table. Do you all understand, everybody? Alfin, Kishore, Mr. Mukesh, any doubt, please let me know. All of you. So very, very important concept it is. So that is what is the significance of electronic configuration. So we can identify, you take helium, only one shell, 2, valency 0. Neon, valency 0. Argon, valency 0. Krypton, 8, last shell, 0. Xenon, radon. So everywhere it is 0. So that's 8 electrons, so that it is completely stable in nature. So that is what you have to remember. I hope you all clear. Any doubt, please let me know. All of you understand, Amma? Girls, boys? So now,
Yes, sir.
how to draw valence cell? Valence cell means the outermost shell. So now you have to tell for these are the 20 elements actually. Your book is given only 18. So now you all should need to do 20 elements you have to draw in our classworks neatly with the atomic number and mass number, everything. Okay. So now first hydrogen. What is the valence cell of hydrogen? Everybody? What is the valence cell of hydrogen? K shell. Next, helium. What is the valence shell? K. Lithium. What is the valence shell?
L.
Yes. What is the valence shell? L. What is the beryllium? What is the valence shell? L. Boron, L. Carbon, L. Nitrogen, L. Oxygen, L. Fluorine, L. And neon also, L. After that, sodium, what is the valence cell?
M.
M.
Magnesium also M, up to argon, you can check it. Aluminium, M, silicon, M, phosphorus, M, sulfur, M, chlorine, M, argon also M. After potassium, N,
N.
and
N.
calcium, N. Okay, understand everybody? So now you have to do that. So, okay, everyone has to do it. Now, and you have to draw this all the structures in our classwork by Hauser. In place of, see, your book, they are mentioning middle nucleus is a black hole. Don't do like that. You have to do middle. Even this is also not perfect. Beautifully, you can represent. So, one proton, middle itself, you write one proton. Two protons and two neutrons. Like that, you write it. Next here, three protons, four neutrons. Here, four protons and five neutrons. So that little bit bigger nucleus you draw, and while drawing itself, all the things you have to finish it. Now your duty is after this class, 20 elements, beautifully you have to draw, and you have to write one more point to this all. You should write the electronic configuration. Below itself, put EC and you write electronic configuration, K1. This one, electronic configuration, K2. Like that. For example, calcium, if you come, what is electronic configuration? Everybody. KLMN 2, 8, 8, 2. Understanding? Suppose sulfur. Sulfur, what is the electronic configuration? Everybody. KLM 2, 8, 6. Okay. Please respond. Like that, you should write at bottom itself. I want to see. After finishing, everybody has to send me the photocopy before 7:30. Neatly, perfectly how to draw. Okay? Everybody. Take the pen and pencil and neatly draw. You must have. And one more point, remember. From the nucleus to the first shell, give some more distance. You can notice it. And then equal distance. Is it okay? Everybody, do you understand? From nucleus to the first cell, little more distance you put, and then little more means don't put 1 acre land, just normally, and then equal distance. Okay, everybody? You have to write electronic configuration. All these 20 you have to draw in our classworks, and you have to make the practice. That is what is needed. Okay, everyone? So please write it, everything, and everywhere you have to represent this notation also. Suppose calcium, 20, 40, sulfur, 16, 32,